Hi everyone, welcome to the Applied Information webinar today. We've got quite a cool webinar today with Walt Townsend, who's sitting with me. And today we're going to be going over a connected cabinet system and also TravelSafely. So how do all these features work? How do they all connect? So today what we're going to do is go over a bit of a presentation. We're also going to show some video, and I'm hoping right before the end we've got enough time that we can go through and jump into a car and actually drive a connected vehicle corridor. So it's going to be pretty exciting, but before I continue on, Jessica's got a couple of house rules to go over.
We are coming live from Jessica's kitchen per usual. The first thing I want to encourage you guys to do, if you haven't been on one of our webinars before, is to click speaker view. That's just going to give you a better view of what's going to be going on and enable you to participate better. We're going to do Q&A as we go along today. So if you will use that Q&A box, some people use that chat one instead, but we really prefer if you use that Q&A in that toolbox by Zoom. So that way we can keep better track of it. If you have to hop off early for any reason, no worries. This will be recorded and sent out in the follow-up email, and I hope y'all enjoy.
Thanks, Jessica. Really appreciate it. And Jessica obviously manages all these things for us, which is absolutely awesome. So what we're going to do is I'm going to explain some of the technology through this presentation, and Walt and I are going to talk about the unit that's sitting here in between us as we go on through this. So let me just make sure that I get my iPad over here with the stream. And we're going to go through a couple of different slides over here that's going to explain what we're actually doing. So I'm going to explain a couple of things like applied information. You know, who is applied information for anyone that doesn't know us? We deployed in about 595 cities in the US with about 17,000 devices. And we're not a massive company, but we're not a small company. We're 75 employees. And majority of that is actually traffic engineers and programmers. So we're constantly developing new features all the time. The core products that we do is connected school zones, the traffic signal controllers. That's what we're going to be talking about today. That's really important. Preemption and priority. We've done a number of sessions on this. I'm not going to go over any of that today, even though that is included in the same unit that we're going to be talking about today. And then the connected vehicles using the smartphone app TravelSafely. That's going to be something that we're going to feature today talking about it. So on the connected cabinet system, there's four main functions. So the four main functions is we obviously do remote cabinet monitoring. So that's monitoring all sorts of different things like AC power fails, if the cabinet's gone into flash, your battery backup system, and many other things. The second thing that it does is pass-through communication. So pass-through communication, that's providing a VPN connection into your cabinet so that you can utilize your Centrax, your Tactics, whichever system it is, to communicate over cellular to your intersections. Then the unit does emergency vehicle preemption and priority, which, as I said, I'm not going to go in today, but the box all comes included. It's not like we charge additional fees or anything like that for any of the additional features. And the other item we're going to be going over today is the TravelSafely feature. So that's, everybody talks about connected vehicles, and TravelSafely is an easy way of showing connected vehicles to everybody. So, you know, I could talk about this forever, but I have the expert over here with me, Walt Townsend, who's actually going to explain some of the features that this device does and actually showcase it.
Okay. So this is the cabinet unit. This is the standard 1U form factor that you would see in the traffic cabinet. This is primarily designed for a 332 style cabinet, but you'll see we use it in NEMA also. And we do have a small form factor that's the same functionality in a rectangular box if that works better for you. On the front, we got the power switch. We got a switch for testing the preamps. LEDs that show us which preamps are active when we're doing our cabinet check, our commissioning check of the preemption. On the back, you got the power input. We've got 2 switchable outlets on the back that you can control from glance from the web page. If you have some piece of equipment in the cabinet that you want to be able to power cycle remotely or turn on and off remotely, you can plug those in here. Make sure people don't just try to use this as an outlet strip, because you might turn it off accidentally. We've got the 4 antenna connections. There's 2 cell antennas because we're using LTE, so that requires 2 antenna connections for a MIMO antenna. And then we've got our GPS antenna and the 900 megahertz radio antenna, which is the backup link for the emergency vehicle preemption. Then we've got our 4-port switch here, which is for connecting to anything extra you've got in the cabinet. That means that we can do a camera in the cabinet, we can connect to the UPS, we can connect to the traffic controller, all without needing any kind of extra switch in the cabinet. Then all of these connectors here are the basic cabinet monitoring connections. Those are the AC inputs, DC inputs to pick up, whether the power is active, is live in the cabinet, whether the cabinet is in flash, whether it's in stop time, picking up UPS battery voltages, picking up green sense from the the output of load switches. We pick up the green sense so that we can validate the operation of the preemption. And then the preempt outputs are here, is how we would send commands to the traffic controller, but we can do that over Ethernet also, depending on what type of traffic controller it is. Peter, did I cover everything?
Yeah, it's actually even got a built-in temperature sensor,
oh, yeah, it's a temperature
humidity
sensor. Right,
and actually one of the key features behind this is it's got a built-in battery inside of the unit. And what that does is when there is a power failure event, it's able to then send that information over the cellular network that there is a power failure event or the network has failed.
Right. Normally you can't tell the difference between a power failure and a comm failure, but since we have our own battery and our own cell modem, we can tell you which one of those has failed.
Awesome. Well, thank you very much, Walt. As I said, Walt can explain this technology way better than I ever could. So the next thing that we're going to talk about is the actual pass-through communication. So what that is obviously we're monitoring and we're connecting to all of these types of traffic controllers here. So, whether or not you've got a Siemens controller and a Conlight controller, and we're doing not just the Cobalts, we're also doing the ASC3s and EOS.
And EOS. So.
And we do Interlight, Nasdaq, Peak, all of the different manufacturers. We're utilizing basically a high-speed LTE connection where we're getting, like 50 megs up, 50 megs down, that you can actually go and stream multiple streams of video. And the important thing is we support, we're an agnostic device. So whether or not you're doing, as I said, Interlight or McCain or whichever one it is, we support them all. And even if they don't do connected vehicle messages, we can even create our own connected vehicle messages with these boxes. So there's a lot of different features and things like that we've built into this that allows us to work seamlessly across all of the different types of traffic controllers and all the central systems. So you can use Centrax, Tactics, whichever one it is, to communicate to all these things. We also support the city's VPN network as well. So what are some of the features in here? So obviously, when you want to connect to a cabinet, well, what are the typical things that we're going to be connecting to inside of a cabinet?
Well, the first thing is the traffic controller, either for picking up the SPAT messages for TravelSafely for connected vehicles, or the NTCIP communications to the traffic controller itself to bring that back to the central system so it can be monitored centrally. The other thing that's popular is remote front panel. Most of these controllers support some form of remote front panel, often through a web page, so we can make that web page available remotely. So for a small city that doesn't even have a central system, we can give you remote front panel on your iPad or your laptop or something. You can get into your controllers just by installing a VPN client on your laptop. Or we can put that VPN client on your Centrax server, your Tactics server, whatever, to bring it back to your central system. Other things in the cabinet that you talk to could be UPSs. If you want to monitor the UPS remotely, we can talk to that. We can support S&P communications to that. We talk to the conflict monitor. Either the OAD5 itself can talk to it directly, or we can just forward that communication so you can run the vendor software from your MMU vendor, at your central system. Cameras in the cabinet, of course, are the other big thing that we bring that back. We can stream up to 4 cameras from a cabinet, and then can facilitate PTZ operation. If we don't support that in Glance yet, but you can bring up the camera's webpage and control it that way. We can support peer-to-peer communication between traffic controllers if you want to link a priority input from one controller to the next one down the street, or link a preempt from one to the other when a railroad crossing clears and you want to clear the next 3 intersections to get a queue of traffic cleared away. We can.
So is that built into like the Siemens controller?
Yeah, most of the new controllers, the Econolite and Inolite and Siemens, have a peer-to-peer capability where the controllers can actually talk to each other. So we allow you to just put the VPN address of another controller in one controller, so the two controllers can communicate with each other through the cellular network.
So we would basically provide them with like an Excel spreadsheet with the IP addresses of each of the controllers that we've created for them on the VPN.
Right.
And they would basically be able to program that into the peer-to-peer.
Yeah, so it's transparent to the controller. You don't have to do anything special with the controller other than put the right IP address in there. And then all the normal peer-to-peer functions should work as they usually do.
And tell us a little bit more about VPN connections, because obviously VPNs are a complex thing, and how do we actually go about setting that up for a city?
We set all of that up for you. You don't have to set up any of the field connections. The VPN capability is built into the OAD5. So when a city signs up to have a VPN, we create a unique VPN for each customer so that you're not seeing each other's intersections, of course. So there's a private VPN that only the city and the city's network can see. All of the units in the city join that network. They connect to our central VPN server. And then we provide VPN clients that you would put on either your central systems comm server or any laptops that you're going to have that you want to be able to access the cameras or remote front panel. So they can access it, or we can work with your IT department to create a site-to-site network between our VPN data center and the city's VPN data center. So larger cities prefer to do that. The IT departments prefer that. That lets them control the rules on what traffic is allowed in and out of the network. They like to be able to configure that according to their safety policies, so we can work with that. And so that's really the only setup required on the city side. And then as the intersections are brought online, each one gets assigned a VPN IP address, and those are the addresses that you would enter in your central system, like your Centrac system, just like you're entering the field address of a normal connection to a traffic controller, but instead of the address on the fiber network, it's the address on the VPN network. So pretty straightforward.
So if they give us, according to you, straightforward, according to me, I don't know. I don't know all this stuff as much as Walt does, but so if they gave, so we would, is this a static IP address then?
It's a static IP. So there's no difference when you set one of these up in Centrax or Tactics. There's no difference than if it was directly on your network. It's just a different IP address.
Okay, so for a city, they wouldn't notice any kind of difference,
right?
Besides running through this or running through a fiber connection.
Right.
The only difference is obviously this is being a managed service that we're providing for them.
To slightly higher latency. We typically see about 300 or 400 millisecond latency to the controller. So if you're watching your real-time signal display in your Centrac system, you might notice a fraction of a second delay on a camera, but you can still upload the database on a Centrac system from a Cobalt controller using FTP. You can upload the whole database in about 20 seconds. So it's pretty fast. So
that's awesome. We spoke about it a little bit, which was Glance Video, and how what we do is we connect to multiple different types of intersections, cameras. Now, obviously, I've got a list of them right in front of me. Can you explain some of those, some of the brands that we're connecting to?
Sure. The most common ones are simply picking up detection cameras that people have out there, like Iteris or Autoscope. FLIR, we've worked with a couple other ones. As long as they can stream MPEG-4 or H.264 video, we can usually pick that up and stream it, or bring back snapshots, or both. GridSmart, we've supported GridSmart. So bringing back your surveillance cameras is pretty easy. We can also bring back more surveillance type cameras or PTZ cameras. And again, you would use the web, you can see them in glance video, but you would need to bring up the camera's web page through the VPN connection to control the PTZ on that right now.
Okay, so Iteris, Autoscope, Econlight, FLIR, Trafficon, GridSmart, and if you guys have got a different intersection, or camera, sorry,
And we've
just
done Axis,
send it to us.
Axis, Kohu, there's about a dozen of them total. That we've
Okay,
done,
Sidewinder, all of these other
WPI,
PTZs and
yeah.
so on. And then what happens is obviously that comes up as a feed in Glance, and you'll see here on the right-hand side of Glance, this intersection here has got 3 different cameras, 1, 2, 3 over here. And when you click on one of them, it brings up a bigger feed over here. And then basically you can see it. You can also maximize the screen. And what we do is we basically stream the video for about 3 minutes. And if you're still watching it, you can click on this little reset button over here. That will give you another 3 minutes. But what that does for you is it allows you to continue watching it, and it allows us to basically go and provide video streaming at a low cost that's not killing the cellular network costs.
Yeah, we don't plan to do it for a 24-hour-a-day stream to a video wall. It's on-demand video is the intention here. So.
And multiple people can also see the same video at the same time, right?
Right. We use a video server so that we only bring 1 copy up from the camera, but then 10 people can be watching that stream at the same time.
Okay.
Just like YouTube. So.
All right, all right. And then one of the other things that you mentioned earlier was remote front panel, and we've seen a massive uptick in this, especially in the communities that have multiple different types of traffic controllers, and also the people that are small communities that don't have the budget to put in a $100,000 central system.
Sure.
Can you explain how remote front panel differs from being right in front of the unit?
At the least, it's the remote front panel acts as a keyboard emulator. It shows you the menus as you saw on the screen up a minute ago, and the keys. Most controllers have a web page that looks something like the front panel of the controller with the screen and the buttons, and then some of the more advanced ones also show you the cabinet I/O, the inputs and outputs at the same time. So even if you're not at the cabinet, you can still see what the load switches are doing and what your detector inputs are doing without having to actually go to that part of the menu. So it's a very powerful way to get to the controllers. Plus, you can do it all, from your study, from your office or whatever, or your truck.
And this helps the whole remote working
Sure.
side of the business where it's been going right now. And tell me, can I use this on an iPad?
Yes, that works on an iPad. We can install the OpenVPN client on the iPad if you want to do the video, but if you're just doing it in Glance, you don't need that.
Just a remote front panel, so you can hit 152 and get to that menu on the controller. And it's also something I suppose technicians know how to use.
A lot of times the field technicians are more familiar with the front panel than they are with the central system. So it lets them get in and work directly with the controller without actually having to go there.
Okay, okay. And I mean, is this second by second, like where you look at the numbers over here, I mean, are these going to change in real time?
In real time, 2 to 5 times a second, you'll see the screens update. You can see it count down a 1/10 of a second timer. So.
Okay, so basically all the operation that you would normally do standing in front of the intersection, you can do now remotely. If it's a cold day, you can sit in your car with your iPad or computer or whatever it is and control these things.
Yep.
So some of the controllers that we've done obviously Interlight, Econlight, Peak, Trafficware, Nasdaq. There are multiple different types of controllers from Trafficware and Nasdaq. And all of those, the ones that I've highlighted right now, they actually provide web interfaces.
The newer ones, the ATC style ones do.
Okay, the only one, this one that we're showing here on the right is one that we actually created because Siemens doesn't actually have a
They have a
web,
telnet interface, so we provide a telnet emulator for them.
so that someone can
Yeah.
actually have the physical buttons over
Right.
here where you can press the different buttons, and we've made it look exactly like a traffic controller
Yeah.
where each of these buttons works correctly.
Yeah.
Okay. What I suggest, Walt, is why don't we go and have a look at a live cabinet that's behind us, and maybe you can explain to everyone how they wire things in and all the rest.
Sure.
All right, Walt, you can walk us in. This is obviously the IATL. You can see this big wall behind me with all of this different equipment ranging from school zones to driver feedback signs to railroad crossings all the way to the traffic signals. And then we've got a 232 cabinet over here, and we've got a NEMA cabinet here. And Walt, you're going to take us through this NEMA cabinet first.
Sure. So this is a typical NEMA TS2 cabinet. You can see we've got our unit sitting here. Normally it would be up under the controller here on the shelf in a shelf mount cabinet like this. Ethernet ports are back here. We don't have this one hooked up right now, but you can see antenna wires here. The antennas are up in the top of the cabinet up here. This is our MIMO antenna. This one over here is our 900 megahertz radio.
And why are they installed on either end of the cabinet?
We'd like to get them as far apart on the top of the cabinet so that they don't interfere with each other. It's not critical that they be exactly where you see them here, but we do want to try to position them a little ways apart from each other. And we also want to know if there was a pole right next to the cabinet here, we wouldn't want to put the antenna right next to the pole. We want it to have a good view of the street.
Okay, so just using a lot of common sense.
Yeah.
Obviously, when you've got a 900 megahertz antenna, that's largely talking about
That's the
preemption.
that's the line of sight backup for preemption.
Okay, all right. And the cellular, that's a bigger antenna than you normally see on a school zone because it's doing the...
It's a dual MIMO, yeah.
And it can do the video
Right,
streaming.
that's the streaming.
When you say dual MIMO,
It actually has two antennas that it can receive different signals at different frequencies on each antenna to give it a higher bandwidth. So higher reliability connection, higher bandwidth.
okay. All right, and now there's obviously all these wires in the back of this cabinet.
Yeah. So
How do they get wired in? What are some of the wires that people need to know about?
they're kind of color coded to show you what they are. The yellow ones are primarily cabinet monitoring. So these are, if you can see down here, they're going to terminals that are telling us when the cabinet is in flash or when it's in stop time. We're picking up the AC voltage coming into the cabinet so we can detect a power failure because, again, we have our own power, so we don't have a power failure, but we can sense the power failure. We report that. The green wires here are the green sense wires. So they're actually wired to the outputs of the load switches here so that we can monitor what the light was actually doing during a preemption. We log that and we can report on that so that if someone has a question after the fact about what happened during a preemption, we can see, here's when the truck arrived, here's when the light turned green.
And I believe preemption, green sense, if someone's got a spat message coming from the controller, we can actually use that.
We now use the data coming from the SPAT message from the controller primarily, but we still wire in the green sense just in case we aren't getting the SPAT at the time as a backup. And then the blue wires here are the preempt outputs, the 8 outputs that go to the controller. They're wired into the preempt input terminals up in the back there. Those are the commands from the cabinet unit to the controller. And with more modern controllers, we can actually do that through Ethernet too. So a number of options there. So we're gradually cutting down on the amount of wires you have to use to monitor this. But some things like the AC input to it, it is critical to measure it with actual wires.
And a lot of this now we do, like detector faults and things like that, we do through NTCIP as well.
Yeah, we poll the controller for its detector status and can detect faults in the controllers or pick up faults that the controller itself has detected. So even if you don't have a central system, we can give you an alarm when a detector fails.
Okay, and then someone could then open up, for instance, remote front panel and go
see
delve into it.
And put a recall on it or something, yeah.
So we're not trying to replace any central system, but we're providing a much simpler interface for technicians in the field.
Right.
Now, this is obviously the,
This is the 332.
What's different on this one?
Well, this is the rack mount cabinet. So this would normally, I mean, we don't have the cabinet, just the rack here. So on this one, the antennas are typically up kind of on the shoulders of the cabinet, not on the very top of it, because the way these cabinets are built, you can't really get into the top of it. But same idea, we put them on opposite corners typically. The wiring is similar. You have to come around back to see it. You can see the wires coming off the back of the unit here. Some of our distributors build their own panels, like this termination panel, which terminates all the wires coming out of the unit, and then they will pre-wire it at the factory into the right terminals in the cabinet. So again, it's picking up, whether the cabinet's in flash, stop time, those things, and the green sense is the same, all the same basic inputs. This one is wired into the UPS controller, so these are actually the UPS controller inputs.
So what do you get from the UPS? I mean, what are we monitoring from a UPS then?
Well, the UPS, we measure the battery voltage directly. We tie directly to the batteries and measure its voltage, so we can track that and look for a problem if it doesn't, if it discharges too quickly when it's used and so on. Plus we connect to the relay outputs on it, so we can pick up the on battery relay and the battery low relay. So if there is a problem with the UPS, the main problem people have with UPSs is they don't know when they're being used. So you put a 4-hour UPS out there, you have a power failure, the intersection switches over to the UPS and it's running fine, but you don't know it happened, so you can't go out there and fix what happened to the input power. It runs 4 hours longer and then it still shuts down. So if you didn't know to go out and fix it, you might as well not have a UPS out there.
So I see there's an Ethernet connection in there as well.
Right.
What are you doing over there?
So a new feature we've added is that we actually talk to the UPS controller over SNMP, over Ethernet, and we can actually command it to run a battery test periodically, because normally a UPS in traffic service doesn't ever have any long discharges, so you really don't know what the quality of your battery is. When we do this with our solar powered devices, they're charging and discharging every day, so we can see the graphs of the battery curves. You can tell if the batteries are working correctly. But on these traffic UPSs, you can't. So we're set up to schedule, say, a weekly battery test to make sure that the battery will run at least a 30-minute test. And we can look at the discharge curve, and if we see that it's not, it's dropping too rapidly or whatever, or if the UPS controller reports an error, then,
just hold on, Walt. I think we're having are we having a technical issue over there?
Ah.
Let me go and let me go to the all right. You guys want to swap over? Apple TV.
Okay. Are we back?
We're back. Sorry about that, Walt.
Okay.
All right, so
Okay.
you were talking about plugging in and the issue of...
Right, so we talk directly to the UPS controller and we force it to run a scheduled battery test, and then we report the results. So we can tell from the results of the test whether the battery behaved appropriately or whether you need to go out and service those batteries. That's the main key there.
Okay, and then I also see a bunch of cameras on top of this as well.
Sure, this one's set up with the Iteris cameras, just in a test situation here. We do several different things, working with different types of detection, including the Iteris. First, we stream the video from it, which is what the Ethernet cables are doing here. Then we can, obviously we said through the controller, we can poll for detector status and pick up things like whether there's pedestrians in the crosswalk. These Iteris detectors will pick up. They have a separate output they can give us when they know there's a pedestrian in the crosswalk in front of the stop bar, or just polling for detector status and looking for failures such as detector stuck on or detector stuck off. So a lot of different things we can do with that.
And so the now you're talking about we can see the stuff with the with Iteris, but we also do, you were mentioning earlier, NTCIP polling.
Yes.
What kind of information would that actually give someone? In other words, would they know, hey, detector number 5 has failed?
Right. We poll, you tell us which detectors are active. So if you are using a certain set of detectors, you mark which ones are active in the glance configuration. And then it'll monitor those for, you can set up what the longest possible on time should be and what the longest possible off time should be. And if they ever exceed that, we'll give you a stuck on or a stuck off error, so you know you aren't getting any actuations from that controller. And if you program detector monitoring in the controller itself so that the controller can report a detector failure or a hardware failure coming from a smarter card like this that can do that, we can pick that up also and give you an alarm. And any of these alarms that we're talking about are things that we can send to your phone as a text message. So as soon as you have something fail, we can let you know right away.
Awesome. Well, appreciate that walkthrough there, Walt. We're going to go and sit down and we're going to talk about a couple of the different reports that we do within the glance system, so that people can actually see what the whole thing looks like. Just want to check, Jessica, do we have any questions?
Yes, we do. We have 2 here.
All right.
Okay. So the first one kind of alludes to what you guys were talking about in the beginning and how you actually wire the units. It says, we usually have an Ethernet switch connected with cable jumpers from fiber optic patch panel. Are you saying we won't be needing a layer 2 switch when we use the applied information RSU?
Well, if we are in a situation where there is fiber there, then we would just connect to whatever switch is in the cabinet. And the only reason we'd be doing that would be, say, to get SPAT messages from the controller so that we could do connected vehicle technology. And we can either plug into the existing switch in the cabinet, or with the newer ATC style controllers, they often have a second Ethernet port, an ENET2 port, and we can plug into that so we don't actually have to be on the city network. But the main purpose of the switch is not for those cabinets. The main purpose of the switch is for cabinets that don't have a fiber backbone, that are isolated for maybe further out in a city, or for smaller cities that don't have fiber where there is no switch in the cabinet. So this gives you a switch in the box itself so that you don't need to add a switch to the cabinet just to connect up the 085 and the controllers, and the controller and a camera or 2. So just keeps it down to one box.
Okay.
Awesome. And then the next question that we have is, some agencies are abandoning the video imaging detection and going with radar as detection. Does your product work with radar type of vehicular detection?
Sure. Primarily that connection goes from the radar device directly to the controller, so we don't need to get in between that, but we can still poll the controller for status and pick up any faults that occur that way that the controller would know about. We can also use it to facilitate pass-through communication. So, for example, if they have a central system from the radar manufacturer that can monitor and do diagnostics on the radar units, we can allow it to have direct access to the radar units in the field through the pass-through communications.
And we've done some advanced features as well with we've integrated to like Wavetronics and Smart Micro and multiple different types of radars where we do collision avoidance, and we do a whole virtualizing of vehicles. So there's a whole bunch of additional functions that we take it to the next level with different radar manufacturers. But primarily, we seen as the communication hub within the traffic controller. And one of the good things is when you switch over to the presentation that I have here, that we're showing a city in, we got one more question, sorry. Jessica, yeah? Yep.
So we have someone asking, is it built on the PoE Ethernet port?
No, the 085 does not do PoE. When we do our connected vehicle device, our RSU that goes up on the pole, that device will have PoE because it's out on the pole outside the cabinet. But this box is intended to be in the cabinet, so it's not doing PoE right now.
Any other questions there, Jess? You good? All right. Okay, so the city that I wanted to actually talk about here was the city of Baton Rouge. And what's interesting about the city of Baton Rouge is they've got about 460 intersections, but they're very typical that, you know, of their, you know, for a big city like them, they've got 460 intersections, but 240 of them are on fiber, and 220 of them didn't have a connection at all.
Didn't have any comm at all.
So what they're doing is they're utilizing our units to go inside of the cabinets to provide that communication. Now they're also doing emergency vehicle preemption as well and travel safely at the city, but one of the big primary goals is they now have access to all 460 intersections within their city versus only having half of their intersections connected. And from their ATMS.now system, it just looks like any other intersection that's connected.
Yep.
One of the other things that we do over here that I'm showing, which is the intersection health report. Now, what's quite interesting about this is it's providing each of the individual devices, whether it's online, the AC voltages, if you've had any failures, and whether or not your network status is all good if you've got a failure, your comms reliability, your cell signal strength. And when you have a battery backup system, it provides you your minimum and maximum of your battery backup. So you can actually see whether or not your battery backup systems are working and whether or not there are any kind of faults in those. One of the reports that I love, and this came from City of Marietta, they came up and they said, you know, one of their major problems is their biggest failure on traffic controllers is power failure events. 90% of all of their failures are power failure events. But they had no way of reporting this to the city that they actually had a power failure event. So what they did was we created a report here that looks at all the individual power failure events. So you can see over here that there were 2 power failure events, and it had this intersection over here had 1 hour and 36 minutes of downtime. And that's just a great thing to look at because they now could go back to their power utility provider and say, hey guys, we had 30 power failure events this month and a total of 12 hours of downtime. So that gives them a huge ability of actually just, you know, having open conversations to improve the reliability of the traffic controllers. One of the key things that we do that I did want to talk about was how we are doing providing these devices. So every device comes with a connectivity and support package. Generally speaking, it's 5 years or 10 years of connectivity and support, and that means we guarantee cellular communication. No matter where it is in the country, we've got 17,000 devices deployed, and we have every single one of them online. You know, whether or not we got to put in a different type of higher gain antenna, whatever it is, that's on us. We'll ensure that all of that communication is working correctly, and we'll upgrade you when things go from 2G to 3G, 3G to 4G, or 4G to 5G that we know is going to happen. It also gives you an unlimited warranty. Knockdown, whatever it is, we will repair the units for however long your device is under connectivity and support. And we provide a over-the-air software update as well as part of the devices. So there's a lot of things that we're not just walking away from anything. When we deploy this, we're in there for the long term because we are under contract that we have to keep your communications working. Now I want to switch gears a little bit and go to TravelSafely. TravelSafely is our connected vehicle platform that allows us to communicate to the public over a free smartphone application. And the best way for me to actually explain this is to actually just play a short video that will actually show you what the system does.
Meet TravelSafely, an app that helps you get where you're going safely. TravelSafely works if you're driving, walking, biking, wheeling, scooting, or skating. Get real-time audio notifications.
Red light.
So you can focus on your surroundings. Get notified when you're approaching a red light or when it's time to get ready for green.
Get ready for green.
TravelSafely works with local emergency vehicles, helping them respond to calls faster. Get notified when an emergency vehicle is approaching,
Emergency vehicle front.
or when to share the road with your two-wheeled friends.
Cyclist. Vehicle approaching cyclist.
TravelSafely tells you when you're passing a school or work zone, and if you need to slow it down. So whether you're on the road or just crossing,
Pedestrian.
every time you open TravelSafely, you're helping make a better commuting experience for all of us. Together. Download the TravelSafely app today and join our community of users committed to making our roads safer.
So obviously you can see that it's trying to build a community. And that's an important thing because it's the first time that you're actually getting citizens connected to your traffic system. And at the same time, they receiving information from you, they sending information to you as well. And I'll explain what it means by that. So, it's the promise of getting connected vehicles, right now, everybody, there's 200 million smartphones in vehicles today. So I know everybody talks about DSRC and connected CV2X and all the rest. And we have all those solutions, and next week we're going to be talking about it. But this is something that can be accessed today by anyone, of any car manufacturer, whatever it is, because everybody has a smartphone. So, there's a number of different applications on the intersections. There's school zone warnings, so we can provide warnings that you're speeding in a school zone. The collision warnings for the cyclists and the motorists, and pedestrians. And then you saw the emergency vehicles getting green lights, as well as broadcasting their messages to the public to say, hey, there's an emergency vehicle approaching from behind, or from the right, or from the left. So we've got, obviously, we're working with on the Google phone, Apple on the App Store. We've integrated to Ford Sync 3. We're busy doing Android Auto. And we're part of the 5G Automobile Association, where we're basically building this and having the conversations with all of the auto manufacturers to get it built in directly into the vehicles. So one of the things that I wanted to try to do was take you guys on a live drive, and I'm going to do that. And I know that if we've got any questions during the live, pipe in Jessica as an audio into us, and maybe we can bring in that as well. So let me go and grab the mobile phone, and let me go jump into the live drive. All right, let's walk outside. Okay, so today we're actually going to be jumping into a Tesla Model X, driven by my friend Bill Wills. And obviously you can see that the Vulcan doors are open at the moment. It's a really great car. It's an autonomous driving vehicle. So obviously, we drive these to learn about all the latest technologies and how the cars are looking at everything around them. But what they can't do is they can't talk forward to the intersections, to the school zones, and so forth. So what we've done is we've learned what the cars are really good at doing and what they're not good at doing. And we're trying to build all of our infrastructure solutions so that we can actually go and see what's happening on that side. Now I'm going to try to show another picture-in-picture video over here of the actual phone, so you can see it a little bit clearer to pop up on the left side here. Let's see if we can get that working. There we go. Awesome. So what we're going to do is we're going to drive up to this first signal that's right outside of the IATL. That's our Infrastructure Automotive Technology Laboratory, where we're testing all of this technology. Now, we've got obviously TravelSafely running at, it's about 120 traffic signals here. And we also have CV2X and DSRC, so it allows auto manufacturers to actually test out all of this technology. One of the interesting things is you can actually see there that it's 70 seconds, or now 60 plus seconds, before the traffic signal is going to change. So I know I've got a bit of time now to wait before the traffic signal's actually going to change. An interesting thing that's come back from the public that's using this is saying, well, one of the nice things about that is I'm a little bit less stressed because, often you feel like it's going to take 2 minutes before the traffic signal is going to change. But when it tells you it's 60 seconds, or right now 40 seconds, I know that I've got a little bit of time to drink my coffee or do whatever I want to do, and the traffic signal is going to change. What you're going to see is we're showing the straight movement over there, that it's 20 plus seconds before it's going to change. And this has been quite interesting because what we do is we don't show you second by second, 15, 14, 13, 12, because it's distracting. And we don't want to create distractive driving. Now, you're going to hear something interesting right now, which is
Get ready for green.
the get ready for green message. And then the signals go green. So what's awesome about that is most people, 93% of everybody, uses the app in the background. Now we connect it to the next traffic signal ahead of us, and saying 5 seconds, and it's just about to change. And before we get to the signals, it's gone green. So we knew that it was red because we could see that, but it was about to change, so we knew it was going to stay green. And as you're driving around the corner here, it's going to connect us to the next traffic signal, which these signals are very well timed. And you can see it's about to change again. Boom, it goes to green. And now we're going to drive through a green traffic signal. We don't show the timers on the green because we don't want to have people racing a signal. So we don't want to tell them that, hey, you've only got 2 seconds left. Yeah, exactly. So no one can actually race towards the signal. And here you can see the left turn is 60 seconds or 50 seconds before it's going to change, and the straight, which we are in. So we show you both signals because that's what you're seeing with your eyes ahead of you. Now, here we're going to go turn left at this intersection. And you can see it's a doghouse intersection, but we're only showing green right now because that's what the signal showed. If there was a green left turn arrow, we would be showing green left and green straight. So as we turn down here, we're going to see something very interesting because we're actually going to drive through a school zone. And boom, it pops up here. And my lovely driver here,
Speeding in school zone.
Speeding in school zone. So that's a great message to provide someone to tell them that you're speeding in a school zone and you need to slow it down. And we've done a number of studies with universities in Florida where they've actually shown that the system is actually slowing people down
Red light.
by 5 to 7 miles an hour when there's an audible message that's being sent out. So, awesome way of showing it. Now, this signal that we're seeing over here is showing us that we've got about 60 seconds before the traffic signal is about to change. So, we know that we've got a little bit of time now before the actual signal changes. So, as I said, with me, I've got little kids that are obviously in the back of the car all the time. This is my moment because I can go and scold them out right now that they're being naughty and get them back in line. Now, very, very interesting is obviously, there's 30 seconds left before the signal's going to change, and you'll also hear that same audible notification. And if you look at the signals ahead and try to look at the actual status, you'll see how real time it is, and this is straight over cellular communication, and it's unbelievable. You've got about a 200 to 300 millisecond delay, and we'll hear.
Get ready for green.
get ready for green, and the signal goes green. So it's a really cool way of providing audible notifications, because majority of our users are running the app in the background. So, you know, this is a great way of actually seeing, you know, hearing all the alerts. And, you know, one of the...
Red light.
Red light running alarm. So that's when you're driving up towards a signal and, you know, you're coming up to it fast and you don't see it, that you get this red light running alarm that provides you a safety benefit, that especially on the intersections and the side roads when someone doesn't actually see what's happening on the traffic signal, you actually get this audible alarm that you're about to run a red light. Ah, that's pretty interesting. There's a flashing yellow arrow ahead of us. You see how we show a flashing yellow arrow, a little striped signal through it. That actually shows you that it's flashing yellow arrow right now, but we don't flash it at the user because that would be very, very distracting. So we're driving through right now. You can see the traffic ahead of us was going slowly. The signal's green. There you see the flashing yellow arrow ahead of us. And as we pass just through the stop bar, we stop showing the actual signal phasing and timing. So this is a great way of showing all of this. You know, easy to see for, you know, for the driver as well. And if you're approaching a red traffic and...
Red light.
I knew the red light running alarm was going to come up there because we were running pretty quickly towards that signal and slowing down. Now we can see obviously here we've got 70 seconds, so I know I've got a bit of time now. So I want to just reach out to everybody. If you've got any questions, please type them into the chat, because as soon as we get back, we're going to try to answer as many questions as possible. We've got 60 seconds left and we've only got one more signal to go through and we're going to arrive back. So type in your questions. You've got the expert Walt Townsend with us, who will be able to answer any of your technical questions as we're going through. So you know, what's really nice about this is you can see that connected vehicles is
Get
available
ready for
today
green.
and easy to deploy with a simple box in the traffic cabinet. And when we get to the future, where we're going to start having you know, more and more vehicles, you know, DSRC or CV2X or whatever it is, we can add those as well as a later stage as well. So you can do it now, you can add it at a later stage, but this is going to give you a huge benefit to all of your citizens today, that they can actually see exactly, you know, connected vehicle technologies working in the field. So you can see ahead of us, this is the IATL in the bottom right-hand side there. And we're going to basically jump out of the vehicle over here, and we'll walk back into the building and try to answer as many questions as we can as we stop. The front of the building. And you know, as we transfer over, just going to have a short pause as we transfer over, and you know, get back to the live stream. And welcome back, everybody. I am going to be handing over to Jessica to ask the questions. So welcome back, Jessica.
All right, let's get started with some questions. So we have someone asking, how accurate will the signal green time predictor work with non-pre-timed signal timing plans, particularly when used with adaptive traffic signal control or centralized systems such as Scoot systems? that are operating in Georgia?
Great question. Great question. Walt, you want to go ahead and answer that question?
Yeah, we're not running any kind of a predictive algorithm. We're just using the numbers that the traffic controller sends us in the SPAT message. So it's up to the traffic controller to predict when it's going to change. That is a little tricky with adaptive systems because it can change while it's running. But for the warnings that you saw us give in TravelSafely during that drive, those were things like get ready for green and the red light running, and those are not affected by any changes in the timing from adaptive systems because those are just based on your clearance times. If you were trying to do eco driving or something where you're trying to time it to hit the next light green or whatever, that does get a little trickier. But of course, with an adaptive system, you're not supposed to hit any red lights anyway. So, yeah, talk to your adaptive vendor about that. But we find it works pretty well with actuated systems. It's pretty accurate. So.
All right, Jessica.
Awesome. We have someone asking, how do you test the CV2X and DSRC that's added as part of Applied Information's RSUs?
All right, so there's two different options. So we've done two different things before. We've worked with vendors that have their own RSUs, Zavari, Comsignia, Lear, Capture, all the different providers of those systems, where we basically, our 085 unit, this unit down here on over here, will actually rebroadcast the SPAT message in J2735, that's a standard, to that actual RSU. If you have our units that are sitting behind us here, there's a little cabinet box over here with antennas that are on the pole that we're going to be talking about next week. This actually connects back up to our box over here in the cabinet, and it's all seamless integration where we can do over-the-air software updates and so on and so forth with the DSRC. And this actually has DSRC and CV2X built into it.
And Jessica, was the question, how do we test it, or what was the exact question?
Yeah, the question was, how do we test it?
How do we test it? We have software that we run in the vehicle. We can drive around and survey the area where we've installed the 095s or other RSUs that pick up all the SPAT and map traffic from the RSUs as we drive through, and then we analyze that and plot it on a map and look at the ranges we get when we get back. So.
Awesome. And then we have one asking about TravelSafely. It says, for TravelSafely collision warnings, do both parties in the vehicles need to have TravelSafely running?
That's correct.
Yes.
So if you, yes, that is correct and not correct. Okay, so generally speaking, yes. If you want the collision warning with a cyclist and a motorist coming towards each other, yes. But we have done other collision warnings for pedestrians in crosswalks. So when you've got a mid-block crossing or you've got a signalized intersection, we can actually detect the push button that there's a pedestrian in a mid-block crossing, or when there's a traffic signal controller, we've integrated to some of the camera manufacturers where we actually detect a pedestrian in the physical crosswalk, and we can provide a collision warning for the vehicle based on the infrastructure getting the information from the actual device. So that's a great way, in other words, of using infrastructure to basically get us, get non-connected vehicle citizens connected. Any other questions there, Jessica?
Nope, that's it. But I just wanted to remind everyone before we sign off that we had a couple questions asking about DSRC, that we're going to speak to that in next week's webinar. It'll be at the IATL Tuesday, 3 p.m. And we're going to be talking about adding DSRC and CV2X capabilities to intersections.
Yeah, and we'll go into a hell of a lot of detail there in terms of what's involved in connected vehicles, like Walt was talking about, the testing and so on and so forth, and how also it interfaces with this unit here in the field. So, we've got 3 major deployments of that we'll be talking about, being here and also in Arlington, Texas, and also in Hawaii. So if you really want to go visit a system, you got to book yourself a ticket to Honolulu and go fly to Hawaii. So on that note, I want to thank Walt. Thank you very much, Walt, for joining us. And until Tuesday, thank you very much.